All right, today we are going to get into cubic roots, all right? And we're going to talk about the difference between a cubic root and a square root. And you should have gotten done taking a look at page 27. So if you haven't looked at page 27 yet in your book, go ahead and take a few seconds to read that, pause the video, and come back to me. All right, so we're going to talk about cubic roots. So a cubic root, as you can see up here, is a three-dimensional. Cube is a three-dimensional. So square roots deal with area of a two-dimensional surface. Cubic roots deal with volume of a three-dimensional surface. So instead of length times width, which is the area, volume adds the height, which gives some three-dimensional space to your shape. And as you can see up here too, just like in the area of a square, the volume of a cube can also be side cubed. So it's the same side times itself 3 times. So for example, 2 times 2 times 2 gives you 8. So if we were to say the cubic root of 8 is 2, because 2 times itself 3 times gives you 8. So that's what the difference is between a cubic root as opposed to a square root. It's actually multiplying the number by itself one more time. And again, you're coming up with 3-dimensional spaces as opposed to 2-dimensional. So it says try to make this a calculator-free exploration. Find the edges of the cubes with volumes of 1, 27, 64, and 125. You may build these with centimeter cubes as well. Well, we're not going to do that, but think about this little first cube that you see. It has a volume of 1. So try to mentally think what times what times what gives you 1. That's correct, 1 unit. So the edge of this 1 unit, all right, it's 1 by 1, so length times width times the height. So this cube is 1 all the way around. All right, and in terms of volume, we would write it as 1 cubic unit. Okay, so instead of the square units like we did with area, the 3 is going to go up in front of the units for volume because we're dealing with 3-dimensional spaces. All right, so let's move to one that's a little harder. Okay, so again, we got 1 because 1 times 1 times 1 gives us 1. So let's take a look at this one here that's got a volume of 27. So that means everything that fits inside this cube or this box is 27. And it's 27 cubic units. Okay. So what number times itself 3 times gives you 27? That's right, 3. 3 units. Okay. So that means length times the width times the height is 3. So 3 times 3 times 3 gives you 27. All right, let's jump to the next one. If it has a volume of 64 cubic units, what are we dealing with here? What number times itself 3 times gives you 64? Right, 4. Because 4 times 4 times 4 gives you 64. So that means length times the width times the height. Okay, it's all 4. So again, these cubes are getting slightly bigger. And then last but not least, what is the volume, or I should say, what is the edge length of a cube if its volume is 125 cubic units? That's right, 5. Okay. Because 5 times 5 times 5 gives you 125. Okay, so now as we work forwards, now as we go ahead and go backwards, all right, take the cubic root of something. So on your calculators, I'm going to bring up the calculator screen real quick. I can find the cubic root by hitting the math button, which is right underneath the green alpha, and going to number 4, which is the 3. You see the 3 in front of the square root, and that's cubic root. So if I wanted to find the cubic root of some number, okay, let's say I want to do the cubic root of 1, I type in the 1 and hit enter, and it gives me my answer. If you had those TI-34s, you can hit the same button. You just got to scroll down to number 4 because your display is big. All right. So cubic root of 1, that means what number times itself 3 times gives you 1? Well, the answer is 1 because 1 times 1 times 1 gives us this answer under the root. All right. So again, just like in a square root, the square root of 1 is also 1 because 1 times 1 gives you 1. All right. So again, what number? This is the root. So if I took this number, multiply it by itself 3 times, I'd get the number underneath the root. So now let's go to the cubic root of 27. Well, we kind of did that problem up above, right? The cubic root of 27 is 3, right? Because 3 times 3 times 3 gives me 27. So that means if I took the cubic root of 27, that answer is 3. Because I can multiply by that 3 times itself to get 27. All right, what's the cubic root of 64? Again, we've done all this work up above, right? That answer is 4. Because 4 times 4 times 4 gives me 64, the number under the root. So the root, the cubic root of 64 is 4. That's the number we multiply by itself 3 times to get that answer under the root. Okay, so that means that's the cubic root. Last but not least is the cubic root of 125, which is 5, because 5 times 5 times 5 gives you 125. So that means that this number, multiply it by itself 3 times, gives me the number under the root. Okay. All right, so now that we kind of got that little introduction, we're going to kind of go with, this is a lot similar to what we did with the square root stuff, but now we're just making it into volume. So what is the volume of a cube with an edge length of 5 units? Well, again, we know that the volume of a cube, if you go back up here to the top, is length times width times height, or side cubed. So if one side is 5, that means 5 to the third power, or 5 times 5 times 5, would give us 125 cubic units. Okay. To find the volume, we have to multiply that side, that edge, times itself 3 times. Okay. Now, if the edge length is 2.5, okay, so again, that means we're taking 2.5 and cubing it. So that's 2.5 times 2.5 times 2.5. We would get 15.625 cubic units. Because that's what we get when we multiply 2.5 times itself 3 times. So that's working forward to find the volume. When you're doing cubic root, we're working backwards. All right, so find the missing number. So if we're trying to find the number in the box here, and we got the cubic root, right, which is 5, that means we have to cube 5 to find out the number under the root, just like we did up above in number 2 for those 4 examples. All right, so we have to figure out what 5 times 5 times 5 is. All right, and if you do 5 times 5 times 5, that's 125. So this is the number that falls underneath the root, because the cubic root of 125 is 5. So when you're looking for the number under the root, you cubing whatever that root is of the original number. So we cube 5, or multiply it by itself 3 times to find that number. Okay. Same thing with the other one for number 2 here in part B, is we take this number and we are going to multiply it by itself 3 times to get 15.625. We did that work up above. So this is the number that goes under the cubic root, because the cubic root of 15.625 is 2.5. All right. So again, just dealing with cubics. It's one more time you're multiplying a number by itself. All right. So again, very similar to what we've done in the past with square roots, just dealing with one more variable. So let's go to part 3. So find x. So some number cubed gives you 27. So some number times itself 3 times is going to give you 27. That's what that's saying. So we can find that answer by just knowing your cubic roots, or again, because you know it's some number times itself 3 times, in the pet you can take the cubic root of 27 to find that answer that is for x. And the cubic root of 27 is 3. So x equals 3 here. All right. And we know that because 3 times 3 times 3 gives you 27. Now, here's where also cubic roots are different from square roots, because remember in square roots, you could not take the square root of a negative number. Well, you can do that with a cubic root, Because if I multiply a negative number by itself 3 times, I get a negative number. So here, again, what number times itself 3 times gives me negative 27? Well, again, I can take the cubic root of negative 27, type that in your calculator, you get negative 3. Because negative 3 times negative 3 times negative 3 gives me negative 27. So a cubic root can take a negative number. You can take the cubic root of a negative number, where you cannot take the square root of a negative number. So now when I take the cubic root of a fraction, all right, in part C, all right, so basically I'm going to take the cubic root of 1 and the cubic root of 8. Well, the cubic root of 1 is 1, 1 times 1 times 1, and the cubic root of 8 is 2. So the cubic root, or the number, if I take 1/2 and cube it, that's our x value. So 1/2 cubed is 1/8, because that's saying 1/2 times 1/2 times 1/2. And again, when I multiply fractions, I just multiply straight across. So 1 times 1 times 1, 2 times 2 times 2. Okay. So now, just like we had in investigation 2.2, where we talked about once we found numbers that were cubic roots, remember, now we're working backwards. So to find those x's in the a, b, and c, we had to find the cubic root of those numbers, passed to the right of the equal sign, to find the number that was missing for x. Well, now we have the root parts, okay, in D and E and F, okay, but we got to find the number under the root. So to work backwards, that means now to find the number under the root, we have to take 27 and cube it. And that's going to be an extremely large number. So if you take 27 times 27 times 27, you get 19,683. That is the number for x under the root sign. So if you were to take the cubic root of 19,683, you get 27. Now on the flip side, on part E, the only difference is it's negative, right? So now I'm taking negative 27 and cubing that. So the only difference between the answer for D and E is going to be negative 19,683. Because a negative times a negative times a negative gives you a negative number. Okay? And again, in F, okay, the cubic root of some number gives you negative 1/8. So what that saying is negative 1/8 times negative 1/8 times negative 1/8. Well, I know negative 1 times negative 1 times negative 1, if I multiply it straight across, is negative 1, right? And now, just to find out what 8 is, 8 times 8 times 8, well, 8 to the third power is 512. So this is negative 1 512ths. Right? Pretty small number. But that's the number that goes in for x here. So the cubic root of negative 1 512ths is negative 1/8. Because negative 1/8 times itself 3 times gives us that. So again, you can see how we can work forwards and backwards. All right. I had to pause the video here real quick. All right. So let's head back to where we're at. So it says, use 2 examples from part 3 to explain what each positive value of x might represent in terms of the volume and length. Well, again, this is kind of like the question that we had in the first one where certain ones dealing with side length. So A, B, and C are dealing with edge length because we're going from a smaller number to get to the bigger number. Length times width times height gives you the value. Where D, E, and F, right, we're taking the cubic root of something to find an edge length. So that means that number that we're looking for under the cubic root is dealing with volume. So again, bigger number to smaller number to bigger number here. All right, and just like we did with square roots, trying to find out which consecutive whole numbers, again, those are counting numbers, 1, 2, 3, 4. So again, remember, whole numbers are your counting numbers. 1, 2, 3, 4, and so on. So if you think about the square root of 10, Okay, the square root of 10. I'm sorry, not the square root of 10, cubic root of 10. Well, we know that the cubic root of 1 is 1. The cubic root of 8 is 2. What cubic number of some number gives us 3? The cubic root of 27 gives us 3. So the radical of the cubic root of 10 falls between 2 and 3. So it falls between 2 and 3 because the cubic root of 10 is between the cubic root of 8 and the cubic root of 27. So which whole number from part 1 is closer to the cube root of 10? Well, if I got the cube root of 8 and the cube root of 10 is here, and we got also the cube root of 27, 10 is a heck of a lot closer to 8 than 27, right? Which means our answer would be 2, because the cubic root of 10 is much closer to the cubic root of 8 in 27. All right, so now we got to try to figure out, okay, without using a calculator, let's estimate the value of the decimal spot. Well, if I got the cubic root of 8, that's a nice whole number, right? Cubic root of 9, cubic root of 10, cubic root of 11, and that goes all the way down to the cubic root of 27. So this has got to be a number very close to 2, right? You know, my guess could possibly be 2.1 or 2.2. So just like we did with the fractions, let's explain how we could figure this out. Well, 2.1 times 2.1 times 2.1, right? All right, so if I took 2.1 and multiplied by itself 3 times, I get 9.261. And if I did 2.2 times itself 3 times in my calculator, that's 10.648. So because this number is over, 2.2 will be too big of an estimation. So 2.1 would be more accurate because I'm still under 10. I'm about as close to 10 as I can get without getting over. And obviously there's more decimal place values that we can cover. So in our last part here, it says which value is greater, the square root of 8 or the cubic root of 8? Well, we know the square root of 8 is not a perfect number, right? If you took the square root of 8, all right, you get 2.82, and of course it goes on forever. And the cubic root of 8 is 2. So obviously the square root of 8 is greater than the cubic root of 8. And why is that? Well, again, when you're taking the roots, this 2.82 squared gives us the radical 8. But the cubic root, we got to take things 2 times 2 times 2, right? So when I'm going back to the root, obviously it's going to be smaller because I got to take that number times itself 3 times as opposed to only twice. So that third extra time is going to make that number smaller. So obviously when I'm looking for roots, if I'm cubing things, right? If I were to say, though, flip that around and say, okay, which is bigger, 2 squared or 2 cubed? Well, 2 cubed is 8, 2 squared is 4, because again, I'm cubing it an extra time. But when I take a root, that root's got to be smaller because I got to multiply this 3 times. We're at like 2.82, number, I got to multiply that only by itself 1 more time. So obviously a square root is not going to be as small as a cube root because I'm only multiplying it twice. And that's one of the differences between the two. So usually when you find the square root of a number and the cube root of a number, the square root of a number, that root number, is usually going to be bigger most of the time, especially if you're comparing the same numbers underneath the radical signs. All right, the square root part will always be bigger. All right, so if you flip it over to the very back of your page here, you have a little matching chart. So what I want you to do, I'll come back to that in just a second. It says slide the cards on the bottom to their proper category. So differences between a square root and a cube root. Well, here's one because we know there's 2 of them. Estimate on a number line. Well, I can do both on a number line. So I'm going to slide these here. So what I'd like you to do right now is I'd like you to pause this and I'd like you to see if you can slide these around and see if you can put the appropriate ones underneath the appropriate columns. And then when I come back from this, I'm going to slide these around and see how you matched up. So like obviously relate to 3D figures, that's one. Can root negative value. Cannot root negative value. Here's different signs. All right, can be irrational. Can be irrational. Area, volume, edge length, side length, and relate to a plane, flat figures. All right, so I want you to put those in the right spots, see if you can write them in and see how well you do when we come back and match them up together. So pause right now and we'll come right back. All right, so the first one is relate to 3D figures. Where should that go? Right, cube, right, volume. 3D figures are cubic because the length times width times the height. All right. So if we can do can root a negative value. So which one can we take the root of a negative number? Cubic roots can do that. Okay. Square roots cannot. So that's where this guy goes. Because remember, -2 times -2 times -2 is -8. But no two numbers, when you multiply them together, can give you a negative number. That's why a square root cannot give you a negative number, and a cubic root can. All right, the symbols. Square root sign goes over here. Cubic root sign goes over here. Can be irrational. Okay? Both these can be irrational. All right? Because there are some cubic roots that go on forever. Remember, an irrational number is a decimal that is non-terminating, which means it doesn't end, and non-repeating. It doesn't repeat in a pattern. All right, area is two-dimensional. That deals with square root. Volume, three-dimensional, cubic root. Edge length is cubic root. Length times width times height. Side length deals with square root. All right, so hopefully things are doing well. Now the last one, it says relate to a plane, flat figures. That's a two-dimensional figure right here. So if I match these up, let me slide these down a little bit. So number line, that's square root, right? Same thing, right? Negative values. Oops, come on. There we go. Okay, so you can see the difference, right? Square root sign, cube root sign. They both can be irrational. All right? One deals with area, square root. Cubic root deals with volume. Square root deals with side length. Cubic root deals with edge length. And again, square root deals with, relates to a plane figure, a flat, where cubic root relates to a 3D figure. So again, those are some of the differences between the two different types of roots, square roots and a cubic root. So the homework assignment for this is right here on page 32 and 33, 47 to 64. You're going to do all of them. So 47, 48, 49, all the way to 64. So I hope you found this video to be helpful.